Wiring electrical outlets in a series configuration is not a standard practice, primarily because it leads to unequal voltage distribution across the outlets. However, understanding the concept can be valuable for comprehending basic circuit principles. Let's consider a hypothetical scenario where you connect 3 outlets in series. You will need 3 electrical outlets and appropriate gauge electrical wire. Step 1 involves connecting the first outlet. Connect the black wire, which is the hot wire, from the power source to one terminal of the first outlet. Then connect the white wire, the neutral wire, from the power source to the other terminal of the first outlet. Step 2 involves connecting the second outlet. Take one wire from the first outlet and connect it to one terminal of the second outlet. Connect the other wire from the first outlet to the other terminal of the second outlet. Effectively, you are continuing the circuit from the first outlet to the second. Step 3 involves connecting the third outlet. Connect one wire from the second outlet to one terminal of the third outlet. Connect the other wire from the second outlet to the other terminal of the third outlet. This continues the series connection, linking all 3 outlets together. In this series circuit, current flows from the power source sequentially through each outlet before returning to the power source. The defining characteristic of a series circuit is that the current is the same throughout the entire circuit. However, the voltage is divided across each component, in this case, each outlet. This means that the voltage at each outlet will be less than the voltage provided by the power source. The exact voltage at each outlet depends on the resistance of each outlet and the total voltage of the power source. A major disadvantage of a series circuit is its susceptibility to failure. If any one of the outlets is disconnected or fails, the entire circuit is broken and current ceases to flow. Consequently, none of the outlets will function. This is because a series circuit requires a complete and uninterrupted path for current flow. It is crucial to understand why series wiring for outlets is not recommended in standard electrical practice. Firstly, the voltage drop across each outlet can lead to appliances not functioning correctly, particularly those requiring a specific voltage range to operate efficiently. Secondly, the risk of a single point of failure disrupting the entire circuit is a significant drawback for practical applications. In typical residential and commercial electrical systems, outlets are wired in parallel circuits. In a parallel circuit, each outlet receives the full voltage from the power source, and the failure of one outlet does not affect the others. The current is divided among the parallel branches, allowing each outlet to draw the current it needs without affecting the others. Consider a parallel circuit with 3 outlets connected to a 120 volts power source. Each outlet receives 120 volts, allowing devices plugged into them to operate at their designed voltage. If one outlet fails, the other 2 continue to function normally because they are on separate branches of the circuit. To further clarify the distinction between series and parallel circuits, let's examine some key differences. Firstly, voltage distribution. In a series circuit, voltage is divided across each component, whereas in a parallel circuit, each component receives the full source voltage. Secondly, current flow. In a series circuit, the current is the same throughout the circuit, while in a parallel circuit, the current is divided among the branches. Thirdly, reliability. A failure in one component of a series circuit disrupts the entire circuit, whereas a failure in one branch of a parallel circuit does not affect the other branches. Fourthly, applications. Series circuits are used in applications where it is necessary to control the current precisely, such as in some types of lighting or control circuits. Parallel circuits are used where multiple devices need to operate independently at the same voltage, such as in household electrical wiring. In the context of motor control, series and parallel circuits play different roles. Series circuits are often used for controlling the speed of direct current, or DC, motors. By placing a resistor in series with the motor, the voltage applied to the motor can be reduced, thereby reducing its speed. Parallel circuits are used in motor control for connecting multiple components, such as start and stop buttons, in a way that allows for independent operation. For example, multiple start buttons can be wired in parallel so that pressing any one of them will start the motor. In practical electrical installations, safety is paramount. The National Electrical Code, or NIC, provides detailed guidelines for wiring electrical circuits to ensure safety and prevent hazards. The NEC specifies requirements for wire sizing, overcurrent protection, grounding, and other aspects of electrical installations. For example, NEC Table 310.15b16 provides ampacity ratings for different sizes of conductors based on their insulation type and installation conditions. This table is used to determine the appropriate size of wire for a given circuit based on the amount of current it will carry. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to interrupt the flow of current if it exceeds a safe level, preventing damage to equipment and reducing the risk of fire. Grounding is another essential safety measure in electrical installations. Grounding provides a low impedance path for fault current to flow back to the source, allowing the overcurrent protection device to trip and de-energize the circuit. This reduces the risk of electric shock in the event of a fault. When working with electrical circuits, it is crucial to follow all safety precautions and adhere to the NEC guidelines. Always de-energize the circuit before working on it, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not familiar with electrical wiring, it is best to consult a qualified electrician to ensure that the work is done safely and correctly. In summary, while wiring outlets in series is possible, it is not practical or recommended for standard electrical installations due to the voltage drop and reliability issues. Parallel circuits are the preferred method for wiring outlets because they provide each outlet with the full source voltage and ensure that the failure of one outlet does not affect the others. Understanding the differences between series and parallel circuits is essential for comprehending basic electrical principles and ensuring safe and effective electrical installations. Always prioritize safety and follow the NEC guidelines when working with electrical circuits.